Hey folks, it's Dr. Gilchrist, and as promised, here is our first pre-recorded lecture for learning and conditioning. Just as a reminder, on Monday, October 5th, we will be taking part in a class experiment, and that will take up a good chunk of our class time. So to make sure that you don't lose speed, because we do have an exam coming up very, very quickly, I wanted to make sure that I had a lecture available for you to watch. So I am probably going to break these up into parts. So this one will probably be about 20 to 25 minutes max, and then I will post another 20-minute one later on this afternoon. So let's go ahead and go full screen, and now we are in chapter 6 of your book. We are talking about learning and conditioning. So here's what we're going to cover in this lecture. And I will mention that for a lot of people, learning and conditioning is one of the trickier chapters, not because the concepts are inherently in and of themselves difficult, but rather because some of the terminology can get a little bit confusing. So I would say this is a case where if you have to watch this again, please do. If you need to read your textbook, if you need to hear me read the textbook, do it. So here's what we're going to cover in this lecture as we cover learning and conditioning. We're going to talk about the 3 different ways that we learn. And we're going to talk about how we learn by what is referred to as classical conditioning. We're going to talk about operant conditioning and how we learn by that. And then we're going to finish up by talking about how we learn by watching other people, which is known as observational learning. So what is learning? So when I ask students to think a little bit about what they think about what learning is, they tend to think about things that are related to academic learning. They think about studying, reading a textbook, taking notes, doing exams, and that is certainly a type of learning. It's a form of learning referred to as cognitive learning, but that is not the only type of learning that there is. Learning is actually a far more simple concept than you've probably been led to believe. And in fact, this is not just something that humans are capable of doing. Learning is actually an instance under which even the simplest of animals can actually demonstrate learning. So learning isn't what we think it is, and it's not just reserved for human beings. Animals of a variety of types have been capable of demonstrating learning. That includes rats and mice, that includes hamsters, that includes dachshunds and dogs, that includes this scary monster fish, which is referred to as a lamprey, pigeons and other types of birds, even fruit flies. And cockroaches. So, for example, even cockroaches, these ugly little things, are capable of demonstrating learning. So what you're looking at here is what is referred to as an inhibitory avoidance paradigm. So here's what we know about cockroaches, and it turns out that rodents as well tend to operate pretty similarly. Rodents and cockroaches tend to prefer to be in darker places, and that makes a lot of sense when we think about it. You want to be in a darker place because if you're in light, well, there's a pretty good chance that somebody could see you, and odds are pretty good that you would not be around for much longer if you were spotted by somebody by being in light. So these animals tend to prefer dark spaces. So what researchers have done is they have created a chamber that has 2 different partitions. So we have a light side of the room, and then we also have a darker side of the room. The lighter side is typically where the animal does not want to be. And so what we're going to find is that animals like rats and cockroaches will prefer to spend time in the darker chamber. Here's the catch though. This chamber has electrical wiring in the floor, and if the animal spends too much time in that dark chamber, they get a little foot shock. It's definitely not dangerous to the animal, but it's also not a very pleasant experience. And so with a few repeated trials, cockroaches can be trained to learn to avoid dark spaces if they are shocked. So by the way, this slide should say cockroaches learn to avoid dark spaces if shocked. So we can actually teach them to avoid areas that they normally want to be in just with the threat of a punishment. So learning is not just about studying for tests. In that example with cockroaches, I very clearly did not give it a test. I did not ask it to take notes or anything like that. Learning is actually a very, very simple process, and it's a very simple definition. Learning is a change in behavior that results from experience. So what this means is that if you want to learn something, you actively have to be exposed to it in some sort of way. There is no possibility for learning if you are not gaining experience. So we learn from experience, and much of the early work that has been done on learning with respect to humans was done through the work of John B. Watson, the founder of behaviorism. So in the early 20th century, this was something that John Watson, the founder of behaviorism, very strongly believed in. He believed that we started as blank slates and our experiences are what mold us and shape us. So we turn out to be the people that we become largely because of the environments that we find ourselves in. So this is a pretty famous quote from Watson from 1930 that really exemplifies how strongly he believed that the environment could shape and mold our behavior. Give me a dozen healthy infants, well-formed, and my own specified world to bring them up in, and I'll guarantee to take anyone at random and train him to become any type of specialist I might select. Doctor, lawyer, artist, merchant chief, and yes, even beggar, man, and thief, regardless of his talents, penchants, tendencies, abilities, vocations, and race of his ancestors. So Watson believed that all you needed to make what we would consider an upstanding, upright citizen versus somebody who is not, like a beggar or a thief, was by experience. I think that's a bit, as we can kind of see, learning is a biopsychosocial influence. It's not just a social influence. And so I think there are probably more factors than Watson would have presumed. But in general, learning happens all the time. Our experiences help us better adapt to the environment that we find ourselves in. And so we are learning all the time. So what are the 3 different ways that we learn? So one of the first types of learning that we have is what is referred to as non-associative learning. We are not making any sorts of associations at all. We're just learning something about one external stimulus. And so some examples of non-associative learning include things like habituation and sensitization. Now let's talk about what each of these are. So I mentioned last chapter when we talked about sensation and perception that our senses prefer novelty. They don't really seem to like sameness all that much. And so what we'll find is that if we are exposed to a constant stimulus, eventually we learn to adapt to it. So I want you to imagine if my phone suddenly started to ring while I was giving this lecture. And knowing me, here's what I would probably do. And I wish I could tell you that that has never happened, but it used to happen all the time. My doctoral advisor's phone would go off in lab meetings and I would jump 10 feet out of my chair and everybody else would laugh at me. But let's say that the phone kept ringing. Maybe not just the once, but maybe it kept ringing for every few minutes or so for the better part of an hour. So the first time that I hear that phone ring, I'm going to jump. But maybe with the repeated phone rings, I react less and less and less. And that's what habituation is. You basically lessen your reaction to a constant stimulus. So think about the 4th of July when you first hear those fireworks. You might suddenly get startled. But then eventually, with the more fireworks that you hear, eventually you will react less and less to them. Your body and your brain are learning, and they're choosing to react less because you are getting exposed to this stimulus a lot. So that's what habituation is. Sensitization is a little bit different. And since we're coming up on what I like to refer to as spoopy season, so because we're thinking about haunted houses and Halloween and stuff like that, sensitization can give a really good example. So this one time I went to a haunted house, and I am one of those people that when I go to a haunted house and I get scared, I start laughing. I don't actually scream or freak out. I just start nervously laughing. And so you go through the haunted house, there are all of these jump scares going on, and then somebody comes behind me after the haunted house and touches my shoulder, and I flinch. Now, under normal circumstances, if somebody had touched my shoulder, I wouldn't have flinched. But because I've been going through all of those scares, my body has become sensitized. My system has become sensitized, and I've become more sensitive to a stimulus that would have otherwise been innocuous. And so that's kind of an example of sensitization. Both of these are types of learning. They are temporary forms of learning, though. They are not meant to last forever, and your system will inevitably adapt. The next type of learning that we're going to talk about is associative learning. And in this instance, somebody is making a connection between two different stimuli or two different sorts of events. And so with associative learning, we tend to break that down into two major forms in psychology. We have classical conditioning, where one stimulus predicts the arrival of another stimulus, and we'll talk about what that means shortly. And then we have operant conditioning, where engaging in a certain behavior leads to a particular outcome. And based on what that outcome is, we are either more likely to repeat that behavior in the future, or we are going to be less likely to repeat that behavior in the future. And so we'll talk more about classical conditioning and operant conditioning within the next few minutes and in the next lecture as well. So here are two different examples of associative learning. So if you've ever been through a thunderstorm, and I think we can say we all have, here's a very easy example of classical conditioning. So one of the things that is always true, light is faster than sound. So that means in a thunderstorm, you are going to see a flash of lightning before you hear the thunder that accompanies it. So lightning will always be followed by thunder. And in your experience, that is absolutely the case. So what ends up happening with repeated exposure to lightning and thunder? We learn that lightning predicts thunder. So I know I do this, and odds are pretty good you do this too. This is a clear sign of classical conditioning. We have two events. One of these is going to predict the arrival of another event, and we show that we know that that's about to happen when we see a flash of lightning and I cover my ears immediately. Or you may wince or brace yourself to anticipate the really loud thunder that you know is going to come. And that shows that you know that lightning predicts thunder. That's classical conditioning. Operant conditioning is going to be a little bit different. So let's say I am hungry and I go to the vending machine and I get a candy bar, and I get that candy bar. Now, in this case, because I engaged in this behavior and got a candy bar, I'm going to be more likely to use that vending machine in the future. Now, on the other hand, let's say that I put money in the vending machine and I pushed a button and nothing came out. I am probably going to be less likely to use that vending machine in the future, specifically because I did not receive any candy. So operant conditioning is basically learning to make an association between a particular behavior and the consequences or the outcome of that behavior. So then finally, the third way that we learn is by watching other people. We human beings are very, very social creatures. And so we can learn by watching other people in one of two different ways. We can do observational learning, where we watch and observe and learn by watching people, or we can model other people. We can imitate what they do. So examples of observational learning are, for example, learning how to do a dance by watching it on YouTube or TikTok or things like that. So we're going to start by talking about classical conditioning first. So how do we learn by classical conditioning? So classical conditioning occurs when we form an association between two different stimuli. So here's what's really critical about these stimuli. One of these has to be a neutral stimulus. And it's going to be paired with something that we call an unconditioned stimulus. So an unconditioned stimulus is something that will normally produce a reflexive response that we did not learn to do. So here's an example. If I take my little metal straw and I shoot a puff of air into your eye, what are you going to do? Odds are pretty good you're going to blink. The eye is going to reflexively close so that you can protect your eyes. Now here's my question. Did you learn how to do that? And hopefully you will realize that the answer is no. You didn't learn how to do this. This is something that you do instinctually. This is reflexive and you didn't have to learn it. That is what we would call an unconditioned stimulus, that puff of air to the eye, because it produces a reflexive response. Another way of thinking about unconditioned is unlearned. This is not something that you ever had to learn how to do to be able to perform it. So this unconditioned stimulus will produce some type of response. So if I shoot a puff of air into your eye, you will blink. And I didn't teach you to blink. That is something that you do instinctually. So probably one of the best known people associated with classical conditioning is Ivan Pavlov, who, as you can see in this photo, has a really awesome beard. Now, one of the things that you need to know about Pavlov is not a psychologist. Pavlov was a physician, but he did receive a Nobel Prize for his work in this area. And he was really interested in studying different digestive secretions, not only those released by the stomach, but also in saliva. So one of the things that you may not know is that your saliva contains enzymes that start breaking down food the moment it hits your mouth so that it makes it easier for you to digest. And Pavlov is known today largely for his work in classical conditioning, which is sometimes referred to as Pavlovian conditioning, because of his very systematic, careful, and thoughtful work about conditioning. So his famous study is this. So here we go. So Pavlov noticed something kind of interesting when he was doing his work on digestive secretions. And odds are pretty good if you have a pet, you've seen this happen as well. My dog so much as hears kibble or a bag open, and he thinks it's food time for him, and he comes running. One of the other things that we've noticed that Smedley tends to do is that once we start putting food in his bowl, he drools like an awful lot. It's really gross. Both of these are things that Pavlov kind of noticed, that whenever he would put a food plate down, and there wasn't even any food on it yet, the dogs would come running. And he was kind of interested in why that was. And so he did a very well-known experiment, a very classic experiment, and we're going to go through this in detail. This is probably the last slide I will cover for this lecture because I want to go in depth with this. So here's what we know. Meat or putting food in someone's mouth produces extra salivation. So that's just a fact, and that is not something that you have to be trained to do. This is something that is reflexive and instinctual by nature. So here's what's going on before Pavlov's experiment. So here, our unconditioned stimulus is food in the dog's mouth. This is an unlearned behavior, and when you put food in the dog's mouth, this unconditioned stimulus will produce an unconditioned reflexive response of salivation. Now, on the other hand, if I take a tuning fork or ring a bell, that is a neutral stimulus. On its own, it does absolutely nothing. And as you can see, if I whack a tuning fork and produce a sound, the dog does not salivate. This dog's really cute, by the way. I like his ears. Here's what Pavlov did during conditioning. And here's what's really critical. The order matters. So he always presented the tone first. So he'd strike a tuning fork, and then he would put food in the dog's mouth. So he'd repeatedly pair the neutral stimulus with the unconditioned stimulus. And the tone always came before the meat. And that would produce salivation in the dog. After several repeated instances of the tone and food, and the tone and food, Pavlov discovered that just the tone on its own would produce salivation in the dog. The dog had learned that the tone always was presented before the meat and began to salivate in anticipation of the meat that was about to arrive. So now, our tone no longer functions as a neutral stimulus. It is now what we call a conditioned stimulus. It is a learned. Another word for conditioned is learned. It is a learned stimulus that produces a conditioned learned response. So now our conditioned stimulus is our tone, and the dog salivating to that tone is our conditioned learned response. So I'm going to go ahead and stop here. I will record more of this afternoon, but this is the basics of Pavlov's experiment. We will talk more about what this means next time. I'll see you then.